Welcome to Mastering Solutions. In this problem, they say that we have a bird that fishes by diving down into the ocean, and they say that it hits the water at 32 meters per second, and they want us to figure out how high it was when it started the dive. And they say that we're going to assume that it was motionless before the dive. So what's happening is the bird's flying along here, and then it flaps, and then it holds perfectly still, and then it starts a dive and free fall, and then hits the water and goes under, catches the fish, and then comes back up. So we're going to be using kinematic equations, of course, but let's write down a list of the variables that they give us in this problem. So we need to know what is the delta y. That's what we're trying to solve for. We know that the initial velocity, we just said it's motionless, so it's holding perfectly still. So that will be 0 meters per second in the y direction, so v initial y. And now the v final in the y direction, they tell us is 32 meters per second. So we need to find a formula that has all of these variables in it, but we don't know how long it was in the air for. So we can't have one that has time in it. So the one that we'll be using is v final squared is equal to v initial squared plus 2 times the acceleration times the delta y. We need to isolate the delta y, so let's move the other variables over. So we have v final squared minus v initial squared is equal to 2a delta y. And now let's divide both sides of the equation by 2a. So delta y is equal to v final squared minus v initial squared divided by 2 times the acceleration. So in this question, what is the acceleration? It's obviously a free fall question, so we know it's going to be gravity, so it's negative 9.8. So we can simplify this equation one step further by plugging in gravity here, but we also can get rid of the initial velocity because we said that is 0. So now we have delta y for the final equation is equal to the final velocity squared divided by 2 times g. So now when we plug in our values, we have the final velocity we said was 32 meters per second squared, and that whole value is squared. Now we'll divide that by 2 times 9.8 meters per second squared. And now it's a negative y direction. So we're going to keep the negative for the gravity since it's moving in the negative y, which will make this whole value negative, which we need for the negative y. So now when we go to our calculator, we have 32 squared divided by 2 times a negative 9.8, which will give us a negative 52 meters. So negative 52 meters is how high the bird was when it first started to dive down into the ocean to fish.